Chapter 10, Section 1, and this talks about just interest. So start us off with some definitions. Interest is the bank that pays for you to basically have money deposit into a savings account. The amount that you initially deposit is called the principal, and at the very end, after all of the principal has been growing, it's called the compound amount or the balance, right? That's probably the most commonly used term that you would call is the balance. What is my balance now? All right. All right, so some definitions here. There are, let's say I give you this chart, and you can see that the date goes from July 1st, 2005 to July 1st, 2006. This is an example right out of the textbook. That's why the dates are all older. And let's say you deposit $100. And so this right here is what we would call the principal. Right? That's your initial deposit. And you can see that it is all in one course of a year. So that means that this piece right here is what we call the compound amount or the balance. Right? So I'll say I'm going to use compound amount. The compound amount. And we're going to say after 1 year. The next thing we can see in this, and we can see that, well, after 3 months here, right, from January to April, we have gained $1 in interest. What this tells us the compound interest rate. And the compound interest rate here, I'll put this up here, this is the compound interest rate. And it tells us that the compound interest rate is 1%. Well, how did I figure out it was 1%? Because if you look at the comparison, $1 of $100 is a 1%. So that means that the interest earned in the first period, which is $1, is 1%. So now we say, what is the interest that was gained? What is the annual interest rate that we've had the whole time? So if every 3 months we're gaining 1%, then what do we gain throughout the life of this year? So you would call this the annual interest rate. And the annual interest rate, the annual interest rate is, we're going to say there's 4 different times it's compounded, right? So the interest is $1, $1, $2, $3, okay? And we're going to say it's 4 because 4 times 1%. It's 1% each time, 1%, 1%, 1%, okay? 4 different times, so our annual interest rate is 4%. All right, so before we get into too many things, we'll talk about our common compounding periods. Here's our common one. So first one is year or annually, which is 1 year. You have semi-annually here, which is 6 months. You have quarterly, which is what we just saw, which is every 3 months. You have monthly, right, which is every month. Okay, and then you have weekly, which is 1 week, and then you have daily, which is 1 day. And you can see in 1 year, annually is once, semi-annually is twice, quarterly is 4 times, monthly 12, weekly there's 52 weeks in a year, and daily 365. So another definition, if interest is compounded m times per year, so this is just standing at 2 times per year, 4 times per year, that's what m is representing, and the annual interest rate is r, then the interest rate per period is I equals the rate divided by the number of times per year it's compounded. So the interest, so another way of saying it is interest equals the rate over number of times compounded per year. All right, and this comes from right here. This number would come from our first column in our last slide. It would come from this column right here. So if it's compounded quarterly, your M value would be 4. If it was compounded semi-annually, then your M would be 2. All right, so here's our next example here. Determine the interest rate per period for each of the following annual interest rates. So A says 4% interest compounded semi-annually. So first I need to identify, write my equation. My interest rate is the rate divided by the number of times it's compounded per year. So my rate is 4%, and it's compounded semi-annually, and semi-annually is 2 times. So my M is 2. And now I can't just say 4% divided by 2. I have to write the percentage as a decimal. So I'm going to write it as 0.04 divided by 2. That will give us 0.02. So our interest rate for this period is 2%. 2%. Okay, there's 2 ways of looking at it. I'm mostly going to leave it here as 0.02, so this would be your final answer. So this is what you would box. If it was in a word problem or a context, it would ask you what is the interest rate, so you have to answer it is 2%. So I'm going to go ahead and pause this. I want you guys to stop the video, and I want you to do letter B, and then when we come back, I'm just going to have it all worked out, and I'm going to talk you through it. So go ahead and pause now and work on letter B. All right, so she got 0.003, which also equivalates to 0.3%. All right, moving on here. Now, new from the previous balance. So for a savings account in which the interest rate per period is I, that's what we just talked about, the interest earned during a period is I times the previous balance. Okay, and I'm going to show you some things. And so this right here, this signifies the new balance. And we add the interest earned during the period to the previous balance. And this is going to be our previous balance. So new balance, previous balance. And we can see that the new balance is the previous balance plus the interest times the previous balance. Or we write it out this way. And this right here is the way we're going to write it out right there. This is the formula that you need to know. I'm just showing you where we get this from. But that formula is the one that we're going to continue to use. And we're going to use it here in example 3. So example 3, here's some key things. It says compute the interest and the balance for the first 2 interest periods for a deposit of $1,000 at 2% compounded semi-annually. So there are some things that should stand out to you. The first thing is that here's my deposit, which is $1,000. I have 2% that I'm gaining here, and it's compounded semi-annually. So if you remember, this tells you that M is 2, because that's how many times it's compounded per year. So I first need to find my annual interest rate, because it says compute the interest and the balance for the first 2 interest periods. So I first need to compute the interest. And how I do that, I say my interest equals my rate over how many times it's compounded annually. So my rate is 2%. It's compounded twice. So I have 0.02 over 2, which equals to 0.01. So what is my interest? My interest is 1% annually. But I'm going to leave this as 0.01 because we are going to use that again. So keep this in mind. We're going to use this here on the next slide. So we're going to continue this. So we found the interest, and now it says find the balance for the first 2 interest periods. So we're going to say that B sub 1 is the balance for the first period, and B sub 2 is the balance for the second period. So let's just say second period. My fault. I had a little typo here. Let's just say second. All right, so for the first period, So if you remember back from our original, we say that we have our balance of our new equals our 1 plus our interest rate times the previous of the balance. So write it up, same way. So the balance of our new, which is balance of what we have now, equals 1 plus our interest, which was 0.01, times the balance of the previous. And the balance of the previous is 1,000. So I can write this one more way. When you put this into your calculator, you will get $1,010. This is the balance of your first interest period. Now our second interest period. That is our B sub 2. And we're going to say again, it's still 1 plus our interest is still the same. But now our balance for our previous is not 1,000, it's 1,010. So when we put that into our calculator, or actually we can do it again a long way, just to kind of show you that 1 plus 0.01 is 1.01. We put that into our calculator and we get $1,020.10. So this is now our balance of our second period. So we have done what the example is asked. It asks us to compute the interest. There it is right here. Compute the interest and the balance for the first two periods. So the first period, the balance would be $1,010. After the second period, it would be $1,020 and $10. So now we talk about the present and future value with compound interest. So let I be the interest period and P the principal, which is the present value, and F the future balance after so many periods. Okay? So we have two formulas here. And really you use both, but you're going to see that this one, to solve for P here, you just divide by all of this. This is why it's F divided by all of that. They're the same formula. All I've done is just move part over to the other side because there's sometimes you need to solve for the future balance and sometimes you need to solve for what the principal is. You're going to see it in the very first example. So this example, letter A said, let's just talk about the beginning. It says, if an account pays 6% compounded quarterly. Well, first off, that gives us quite a bit of stuff. 6% compounded quarterly. Well, if an account pays 6% and it's compounded quarterly, first I can find what I is. So here's I. Remember, I is your rate divided by your M. And your rate is 6%. Your M is quarterly, so we're going to say 4. And so your I is 0.015 when you put it into your calculator. Remember, your N is the number of periods. Just keep that in mind. Okay, so letter A, find the amount in the account after 5 years if $1,000 is initially deposited. So what does it tell you? It tells us that our principal is $1,000. It also helps us find our end value because our end value is the number of periods. Well, if after 5 years, I should know how many periods per year and then multiply that by the number of years that we're in. So far, it's only been 1 year, but now we're extending it further. And so we say, all right, well, if it's quarterly, it's compounded 4 times per year, and there's 5 years. So our N is 4 times 5, which is 20. So now we have our values. We have 1,000 for our principal, and our N is our 20. So F. from our previous formula is 1 plus 0.015 to the 20 power and times 1,000. We put that to our calculator and we get 1346, so $1,346.86. So next we're going to find the amount that must be initially deposited if $3,000 is needed in 5 years. So we're not given the principal now, we're given the future balance that we want. And we're still talking about 5 years. So what has changed? Our interest rate's the same, still 6% compounded quarterly. But now our future balance we want is 3,000. And our N is still the same. It's still compounded quarterly, 5 years, which is 20. So we're using 3,000 and 20. And now we're using the other formula that says P equals. So P equals 3,000 over 1 plus our interest rate raised to the 20th power. You put that into your calculator and you get $2,227.41. All right, you're gonna see this whole section is loaded full of definitions. There's a lot of things that are loaded full of definitions. So we have two more. So there's something called compound interest. If you've noticed, I've said a lot of compound interest. And compound interest is when what we have been using, okay, up to this point, like I just said, that's what I just read, it is when the interest gains based on the current balance. The interest keeps gaining based on what the balance keeps happening. So at the end of 1 month, say that quarterly, at the end of the first quarter, we have this amount of money. Now our interest gained based off of that. Simple interest is only earned on the principal and has an annual interest rate. It's only earned on the principal. It's not after the end of the first quarter, then you have a new principal that you're gaining interest on. You are only earning based off the original principal. And this and, I want to make sure I point, it's not just on the principal, but it has an annual interest rate. All right, so its formula looks a little different. So the future value formula for simple interest, if R is the annual interest rate and N is the number of years, remember not how many times it's compounded, but the number of years, then the interest equals NPR or NRP, however you want to look at it. And then the future balance is 1 plus the number of years times the annual interest rate times the principal. This is what we use it for right here. That's really what we go to a lot. Okay, so let's get to the example. This example says calculate the amount after 4 years. So here's our important part. So 4 years, and it is $1,000, and it's at a, sorry about that. It's at a 5% simple interest. Those are our three things. So we know that it's a simple interest. We're going to keep it there for 4 years, and we're going to have an initial deposit of $1,000. That's our initial principal. So our future balance, remember it's 1 plus NR times P. So 1 plus our N is our 4, number of years. Our rate is 5%, so it's 0.05. And then our principal is 1,000. When you put that to the calculator, you will get $1,200. So your $1,000 after 4 years has grown to be $1,200. Moving on to our next definition. It's called the effective rate of interest. It is the simple interest rate that yields the same amount after 1 year as the compound annual rate of interest. The effective rate is also known as the annual percentage rate, the APY, or the true interest rate. You're going to see it mostly as the APY. So let's go ahead. I'm going to give you the formula, and then we're going to do an example. A lot of formulas right now. So formula, if R is the annual interest rate compounded M times per year, then the interest equals R over M, and the effective rate of interest equals 1 plus I raised to the M power minus 1. And I put down here, even though I just said it, make sure R subscript EFF represents the effective rate of interest. Okay, so that's what we're going to say. We're not going to say the ref. So it says calculate the effective rate of interest for a savings account paying 3.65% compounded quarterly. Well, we're going to get right into what we're just given. So the effective rate of interest, so here we go. And the formula is 1 plus I raised to the M minus 1. I encourage you to write the equation every time you use it. That way you get more ingrained into what you're trying to look for. All right, instead of trying to look, oh, what was the formula again, or where do I have to locate it? Now, our I, though, what is I? I'm going to write it further because I gave you this equation, but what is I? And I was R over M. So now we have all of our variables that we need. We need R and M. That's all we need. We need our rate, and then we need M, which is the times per year. So we have 1 plus our rate was right here, 3.65%. So we write it as 0.0365 over compounded quarterly. Quarterly means that we are doing 4 raised to the 4th power minus 1. When you put this into your calculator, you get 0.0370. So the effective rate of interest is 3.7%. Or we can just box this. We can say 3.7%. If you're, just to recall real quick, how do you go from a decimal to a percentage? You just move this over 2 times. There's your 3.7. So that's the end of the first section. And now what I like about this text, it gives you a summary at the end of every section. And so I'm just going to basically leave this to you, and I'm going to scroll through it. You can pause it and read it. But these are the big things that we talked about. Okay, we talked about the money that's put into an account. It gains interest. It's called simple interest, a compound interest. We talked about how to find the new balance based off the previous balance. We talked about what these variables represent. P is our principal. R is our annual interest rate. I gave you the formula for how to find your principal and future, right, balance. Our I is compound interest rate, or we could also say R over M. M is the number of times per year. N is the number of interest periods. F, again, is your future rate. And notice how I put, your future value. It talks about your compound interest or your simple interest, right? They're 2 different formulas. And then lastly, you have your effective rate of interest. It's the simple interest rate that yields the same amount after 1 year as the annual rate of interest. And there's your other formula.